Yeah, it's another session we have, the 10th to be specific, and we are winding up the series today. That is Rethinking Software Development, and it has been a journey all the way from session 1 when we started with research, moved over to design, moved over to implementation, discussed about security, hardening the build, and all those previous sessions that we've had. And as we are faced, as we are part of a society that experiences problems, and as professionals, we need to build solutions in ethical ways. Today, we delve into ethics of software, uh, ethics of software engineering, and also we bridge it with the economics that affect all this. And that is the best way to wrap these up as a session. And our topic for the day is craft, profession, and practice. So the ethics and economics of what we work on every day, would like to delve deep into that today. So Joe Karanja is my name. I'm a software engineer by profession, and I normally specialize in building teams also, other than software engineering. So we've worked on our flagship product. And as you all know, that since we started this series, we have been building a product alongside, and that is Zetu. That's a fintech product that we pool money. It's for pooling money for groups. So most of what we've been covering in all these sessions, we've been relating it to a live product that we've been working on, and that is Zetu. So we start with a simple story that happened back in 2012 of a crisis where money was lost because of a small mistake in the code. So sometimes you can work on code, deploy it, but a bug in production can cost you millions in the process. And most of these things can be overlooked during development or as you are working on the project, and you'll come to pay for all these decisions later on when something goes wrong in production. Remember, we've also looked at some production standards that we need to adhere to when we are deploying any solution out there. So, so when you look at this case scenario for what happened with Knight Capital, there is a lot of money that was lost because of dead code that had been in the system for 8 years, and it took the team time to rescue all this. So there's a lot of resources that were lost, and there's also resources that were used to recover what was lost. So it was not because that the team was not competent. Mostly, it does not happen because professionals didn't adhere to the discipline during programming. But these are stuff, this stuff that shows up because of some overlooked specifics in the systems that we build, and we are going to look deep into it. So, of course, we've looked at configuration management back in session 3. We've checked on software testing back in session 5, where dead code sitting in production can cause chaos in the long run. We looked at operations in the last session. So no kill switch runbook, humans debugged live while the system still bled money. So sometimes when it's too late, you're already losing money. That is on the software itself, and it can, for our case, let's say data is exposed or there's a breach in our production instance of Zetu as a product, people are losing their money. Just imagine, contributions are being channeled, and it comes to a point where now money is lost because there is an error. There was an erroneous code inside the system that was not looked at, and it bleeds a lot of money. And also engineering teams are using time and money also to recover it. So real people's pensions or savings which were moving through the platform were actually being lost in the process. And let's look at what were the factors that might have led to all this. So we've been measuring most of the sessions that we have been covering from Swibok, and software engineering is a load-bearing profession comparable to any other field, let's say to medicine, to civil engineering. So there is a duty of care that we need to have as professionals, high accountability to individuals, unable to directly evaluate their output, and there is also shared standards that hold a unified baseline of quality and security. So even as we mention ethics, most of the time we might mention ethics, but we fail to maybe realize where they come to play even in the simple engineering decisions that we make. So there are some engineering decisions that you make that are actually ethical in nature, based on how do you choose to handle data in the platforms that we build, and how do you display professionalism even as you're engineering. Remember, engineering as a profession, as a professional, there are some decisions that you'll make that will affect the output of the product that you're building, and they will also play as ethical decisions. So I'll draw most of the scenarios from what we are building with Z2. So for Z2 platform, users cannot personally read code bases, verify validation pipes, or audit any complexity inside the payout algorithms and all that. So most of the case, they are depositing their own money, they are moving their own money, but they cannot verify. So there's a gap here where you are the professional, you understand the engineering aspect behind the system, but your clients might not. Some of them might understand, but majority, most in the biggest case scenarios, your clients don't get to understand the technicalities behind it. So it's all built on trust. Most of the platforms that we use, you trust that whoever puts the system together has figured it out, and it's going to function well. And this is in most of the cases where you as an engineer, the decisions that you made, your professionalism in how you put systems together comes into play, because if anything goes wrong, you are the one to blame. So we look at some ethical principles in action, and we'll see how they relate to our day-to-day products that we get to build. So one of the principles is the public. So you need to act consistently with the public interest, the end users, not just the product owners. So most of the time when you're building any product or when you're implementing any solution out here, there are different players. You find there are the people you're building it for, and they are the stakeholders. That is the owners of the system. So sometimes you have to adhere to what the users really, the interest of the users, and here we are calling them the public. So drawing an example from what we are currently building is deciding not to deploy a half fintech some time before because user money deployed outranked deployment vanity. So sometimes you might delay even deploying stuff. Stakeholders might force you, we have to finish this in a month, we have to complete this software in 2 months. But again, instead of deploying something that is not secure enough, you choose to delay that first, so that you first secure your software, you first act on the public interest before releasing something out there. Then there's the product. It demands that you ensure deliverables meet the highest technical standards possible. Then there's judgment. You have to maintain integrity and independence in professional evaluation. And then there's profession. There is the overall integrity and reputation of the collective discipline. So organizing standards, workshops to write down engineering baselines. So practices outlive single developers. That is a professional decision on how you even maintain code standards. There's a session that we covered mostly about code programming standards, and these are professional decisions that you get to make. This is how we'll write the code. This is how you structure different aspects. So same case here. In terms of maybe for this scenario, I've tried to go quite deeper on each and every of these principles. That is the public, the product you're building, the judgment, and the professional aspect of it. So let's look at some cases of what we shall address now in a Kenyan context. So of course, we will be processing financial and demographic data. So these are phone numbers, transactions, names, emails. These we can say PII, personal identifiable information. So when we're processing these, of course, there are some factors that we need to adhere to in the process. Like we have the Data Protection Act, of course. It depends. For Z2, it's something that we are building to run within Kenya. So you have to adhere to this. So for different contexts, maybe your solution is supposed to run in a certain geographical region. You need to also look at the ethical implications around it. Like what policies do they have on different areas, data protection and many other policies. Mostly as engineers, we might tend to only focus on the technicalities of it, deployments, but overlook these aspects. So what happens when something goes wrong? So if there is a breach, a data breach, how many of us have received emails from certain providers that, oh, we are sorry, we leaked your passwords, so please change your password? You've ever come across such context where you are informed, maybe by a provider of a service that you have subscribed to online, that there was a breach somewhere? Even notifying your users is also very important. It's ethical. It's a professional thing to do. So, of course, critical moral compromises often dress as technical layout issues. So professional engineers look past the code to identify structural obligations. So before we even push Z2 to production and for users to use, of course, we need to comply with some aspects like the Data Protection Act, especially when you're dealing with a software that has sensitive, let me just use the word sensitive data or sensitive information. It's important. In case of there is a chaotic breach, then we need to notify the users of our system that there has been a problem here. And also, we are supposed to be, as engineers or as the engineering team behind the solution, we are supposed to have set up structures that notify us in case there is a breach. So a team that cannot detect breaches cannot meet it. Structured login, sentry alerting, health endpoints, and that's why even when we were dealing with the implementation sessions, we had those sections where we log things. So if an admin logged into the server, we need to log that information in production. If someone has done something, anything, if any operation has been performed at an admin level, then that needs to be logged. And it's very easy for us to detect breaches in the process. So an ethical decision often wears a technical disguise. So a good example is, as an engineer, you might ask yourself, should I add that logger library to do logging? Sounds like a preference. It's really, can we tell members within 72 hours if their data leaks? Professionals learn to see through the disguise. So sometimes there are some stuff that you'll get to, there are some decisions that you'll make that are also ethical in nature. So it's a legal requirement that you become aware of breaches. These are just examples that I could draw. Of course, they might be more scenarios or more requirements that you might need to apply under different contexts. So becoming aware of breaches, establishing what happened, notifying within 72 hours. You can even decide it can be within 36 hours, 48 hours, 12 hours. It's a decision that you get to make based on the platform that you are building. So ethics tells you what you owe, and economics tells you what it costs. So the deepest professional skill is refusing to treat those as opposites. So most of the parts that we just checked earlier are ethical. How are you handling data? How are you informing your users? There is some aspects in softwares that we develop, and you know of stuff to do with feedback. Your users need to get feedback from your system. Have you seen a scenario where when your information is shared, it's like you are informed? Or when, let me just use a very simple example that we can relate to. Have you seen the scenarios when you're joining a group, you are told, when you join this group, your contacts or your personal information is visible to everyone on the group. There is such scenarios. Or when you are on a virtual conference call and someone starts recording, maybe the host, there is normally that pop-up that comes, this meeting is being recorded. So even feedback, like informing your users in the process of what is happening in case data is involved, yes, the software will still work, everything will still work perfectly without having to log, without having to inform, without having to be ethical about it. But it's you as a professional who carries the responsibilities to safeguard your users and to inform them in case there is a breach and to protect even the data that your users have. Remember, when your users were were signing up on your platform, they did key in their personal data and they entrusted you as the professional to keep it safe. So it's very important. So now we look at so most of the time we've mentioned terms like technical debt, we've mentioned terms like cost, but let's look at the economics behind all this. So we'll have some factors here. The first two are voluntary and bounded. The last two are imposed, and only their probability is in your control. So we start with prevention, appraisal, internal failure, then external failure. So before failure happens or before chaos happens, let's think of a scenario where your system has leaked data. Maybe you leaked, think of maybe your platform was a wallet that had it can be virtual assets, and you leaked their passwords, and everyone can now log into any other person's wallet and access. So that is a failure already. But before we get to a failure, there are some stuff that you can already do. Prevention. So you stop the defects from existing. A very good example from code that we write are the data transfer objects or validation. For the UI, you might be dealing with forms that validate the information that you're keying in. And even on the server, before your code reaches to the backend, there is some validation pipes that we put in place. We expect a user who is signing up to send a JSON object that has the following properties and values. So if I find that you're supposed to give me your name, okay, maybe let me just use a very simple example. You are signing in. I expect you to give me your email or phone number and your password. And the structure of the object I expect to key in or to query my database with is supposed to be your email or your phone number. So if the client or the front end is sending an extra field that I don't understand, then that can be a point where even attacks happen. So having validation pipes prevents those kinds of problems. And then, of course, finding defects early. Test-driven development is really good at this. So testing as you build, having quality gates, and we checked even in session 7 and session 8 about this kind of defects. And then internal failure. So when you are still building, maybe a failed continuous integration run, a bug fixed in staging, a reverted merge. So before we even deploy, we are still testing. Is it working? So you might catch a bug just before it goes to production. That's an internal failure, but it has not yet reached the users. And then there's the external failure that reaches your users. A wrong payout, a leaked phone number, a 72-hour notification letter. So for a savings platform, an external failure in the money path does not cost a bug to fix. It costs the trust of the entire product. If someone had trusted your platform to save their money in or to pull their funds in, and you accidentally leak their information, then trust is lost. Yes, the bug might be very small. It might be some commented code somewhere that needed to be some commented code that needed to be uncommented, but it doesn't cost you to fix that bug, but it costs the trust of the system. Just ask yourself, if you logged into your banking app and you have a balance and you checked and realized that it's zero, only for them tomorrow to say, oh, sorry for that, we had messed up some variables. That's why we are not showing you the balance. Now your balance is now maybe 20,000. You lose the trust in that platform because again, you got a scare. So sometimes trust is eroded because of some quality faults. And you see, when we get back to the software economics of this, there is loss that you are losing in terms of costs to do with repairing or eradicating those bugs, costs to do with users, you are losing trust. So it costs you the trust. Sometimes costs might not be in terms of money also. Some aspects like trust can also be cost. So, and you can see the degree of failure based on every level. So you prevent, there's a one-time cost base. When it falls to the second level and it keeps on getting dangerous, the more it leaks. So it's good, by all this, we can see that it's good to prevent before it gets there and have a number of fallbacks, like write standard code. When we were talking about implementation standards, coding standards, write code that is good. Make sure that your code is up to the standard. 2, test-driven development. Try to have test cases for what you are writing to make sure that it's not going to fail. Like test cases normally kind of mock production environments before you actually get to production. And then from the test cases, try to have the continuous integration before you push that change to production. Try to check, is it good? Is it going to cause any chaos? That's why we have staging environments, and we mentioned that in previous sessions. And finally, when it gets to production, try to log so that you can detect breaches before they actually happen. So most of the mistakes that happen to production software are actually not hackers. Sometimes they are mistakes that developers left out some trails and commented code. There was a part that you logged an access token. Maybe the developer was debugging the login and they were logging the access tokens just as a debugging method, and then they forgot to remove that part and it went to production. And when people inspect your page, maybe they can see access tokens and use them to access other things. So some decisions cost us, and it's good to be professional even as we're doing it. So shipping code, isn't right, is shipping code, is not right, is borrowing. So you've heard of technical debt, but let's try and look deeply on how this gets to cost you. So you reach the market sooner and pay interest until the principal is repaid. The failure is not taking the loan, it's taking it without recording it, pricing it, or planning repayment. So sometimes you can ship a product that has a pending feature. Oh, we are going to add that later. Oh, it's only validating our users. Okay, we are going to add it later. So that cost is not affecting you during that time of the decision. But when it's being used and your system now has millions of people you have the traffic in your platform and you're trying to do the same thing, it's going to cost you way more than it would have costed you when you just did it during development. So some things are cheaper to implement before deployment, but after you deploy, they become more expensive. And that's why I'll try to use examples from what we are really working on, because some of these points are difficult to capture when you've not experienced them from a project that you've worked on. So there is some parts for that where we deferred some aspects. So for example, a scope loan recorded on the Kanban with a defined repayment milestone. So we've deferred some parts, like payouts, we deferred at some point. But again, we're going to get back to that part and build it. It's going to cost us time, and especially if you've pushed it like a prototype or an MVP and you're trying now to patch most of this in production, it gets to cost you. So deployment, scaffolded reminder, feature stubs, and let's look at the same modules or the same examples that we deferred for Z2 and try to see some of the decisions that we also made that might point as technical debt, and we'll get to see that even as we continue the slide. So we have scope loans, collateral posted, and low interest stubs. So for this second part, collateral posted, deployment was scaffolded in the previous session, and we placed endpoints. For the low interest stubs, The contribution reminders were stubbed out cleanly behind rigid interfaces, isolating code dependencies and keeping the eventual integration cheap. So these are some examples that we have. These are some decisions that we made in the code that we chose. Let's not deal with this now and deal with it at a later stage. But again, that is technical debt. But it determines the cost of it based on which stage we are going to deal with it. If we decide to push something to production and we've not finalized the development of those functionalities and people are already using, it might cost us more rather than just completing them at a later stage. And there is one aspect here that I would really like to point into. So building where you differentiate and integrating where you don't. So these are something that happens most of the time when we are working on a product. Have you worked on a system that you can start from scratch? A good example is Auth. I can do authentication from scratch, write the JWT logic from scratch, and it's going to cost me time. Or I can integrate other providers, let's say Supabase or Clark for my Auth, and I'll still finish it out. So what I'm saying is, when you are working on a product, you are looking at what are the unique functionalities that you're building. Like for Zetu, our unique functionalities is the pooling of money and doing the ledgers. But if you focus on building parts that are not the unique parts of your software, then they might cost you. Let's say I focus on doing an Auth. My software, let's say it's an e-commerce software. I just want people to order stuff online, but I am focusing on implementing authentication a lot. So I would rather focus on doing the unique part of it and integrate existing libraries for authentication, and with that I'll save on cost. So for example, for Zetu, we chose not to do the payment rails. We chose to use Daraja Safaricom. It's already there. It works. But we would have decided, let's do our own payment rails from scratch. It would have costed us time and our energy, but it was there. That is not where we are differentiating. We are differentiating at the pooling of funds and the recording of like keeping a ledger. Let me just call it a ledger. We're focusing at the ledgers of what is happening for all these groups, but not the actual movement of money. There are already existing platforms that do that. So build versus buy. So if we were doing a custom rail, it would have costed us months of work, heavy regulatory licensing. Of course, when you're dealing with money, there is some ethical costs, there are some legal costs. Let me just say that. Risk. The risk here is end-to-end money flow liability. If anything goes wrong, you are the one who is liable, and zero competitive advantage, because when you're doing it from scratch yourself, that certain aspect, it's costing you more than just integrating what is there. But when we decide to integrate like the Daraja API, days to sandbox, callback setup, so we are saving on time. In terms of money, holding money and those licensing, you don't have to go through that process because someone else is doing it for you. And where do we focus? We focus on delivering the unique value proposition for Zetu, and which is pooling groups to come together and pool funds on the existing platforms, that is Safaricom and all that. So sometimes you might be tempted to do even chat interfaces on your app, but you forget the existing platforms where people communicate every day, like WhatsApp. And it's good to think, can my platform work with WhatsApp, and I can focus on where I'm differentiating, and that also saves on the cost, and time is also a cost. The more time you take to build your project, it's costing. So I've mentioned this before. So professional engineering is what it looks like when ethics and economics agree. So for us to engineer anything, any product, software, professionally, you need to match the two. So the ethics and the economics, and the examples that I had narrowed down to in the few minutes that we had is at least making sure you are there to data protection or for your on your platform, and feedback is very important, especially when you're dealing with money, and users get to trust your product even when they don't understand the engineering technicalities behind it. So that responsibility and liability comes back to you as a professional. A very good example is you might be in a scenario where you understand when I use this tool, it might cost my users their security or their privacy. Let me just use privacy as an example. Maybe you use a library in your platform that costs your users their privacy or their security. They won't know that, but you can push that. No one is going to question your choice, because again, users might not understand the technicalities behind it. But you as a professional, it's up to you to decide, I'm going to use a library that maintains the privacy of my users. I'm going to code at using good standards. Sometimes you might write spaghetti code that is jumbled up all over the place. Users will never know how your code looks like. But again, as a professional, it's up to you to choose, I'm going to do it right. I'm going to implement security in whatever I'm building. And those are some of the aspects that we are looking at here. So even as we wrap up this entire series, we thought it's good to look at the professionalism. I know it's a topic that is not really that technical for us as engineers, but it's good to also factor in this stuff. What are the economics of what you're doing? What are the ethical implications of what you're doing? And how do your engineering decisions actually measure to be ethical decisions in disguise? So sometimes you might make a very simple decision. Oh, we're going to use multi-factor authentication. So that looks like it's just that's a technical decision you made. But ethically, you made sure that your users are safe when they used it. There are some questions that normally rise in our teams, even as you're building it. Like a good question is, let me just use Zetu, for example. Who should invite a member to a pool? You see, a pool has a pool member, right? That group has members. Who should invite members to that group? Is it anyone, or is it the pool admin? There is that aspect. So as an engineer, you can implement any of the two. You can even decide anyone can invite anyone. It's going to work. But again, ethically, it's good to look at some aspects of if even the best example here is who should withdraw money in a pool. Is it any member, or is it the pool admin? So that might look like a technical or a logical decision, like of course the pool admin should be the one to withdraw the money if there is wallets involved. But again, as an engineer, you always remember it's possible for you to make sure anyone can withdraw the money. So both scenarios work, but there are some decisions that you make technically that affect that are also ethical decisions in disguise. So as we build, and we want to maintain the professionalism, and that's why later before here we mentioned about a body of knowledge. I think somewhere here, let me just go back there. Yep. So some certain pillars here. Body of knowledge, codified architectural patterns and execution practices, duty of care, high accountability to individuals, unable to directly evaluate the output, shared standards, holding a unified baseline of quality and security. So these three parts here are very important to you as an engineer, because you look at the second one there, for example, it's your duty to care for your user. So if you are implementing a solution that leaks user data to attackers, are you really caring for your users? So some of this stuff might look simple, but they really matter. Shared standards. So we have a unified baseline of quality and security. What we're building, we make sure it's it meets the quality baseline, it meets the security baseline. And of course, there's a verification gap because we have these 3 pillars, yes, but your users might never verify whether you are accountable to them, or you are adhering to standards, or you are part, or you are a professional. It's up to you to, as a professional, to choose, I'm going to do it the right way. We've rethought software development. That is from the first session to this final 10th session. And we've mentioned all the technical things that we could have in that span of time that we had. And it is very important, even as we wind up, in any software that you get to build out there in future, or in any product that you're building out, you hold up the professionalism aspect of it, and also you make sure you adhere to some ethical standards, because trust is a cost that can be lost if you don't adhere to this standard. Sometimes you might lose the money in case of the hackers or software that had dead code in it because of poor standards, and it costs losses. Sometimes it can't be money being lost, but in other scenarios, there is stuff like trust, losing trust. You are a professional, you have a career, losing your reputation also. You don't want to be associated to a software that failed, or no, who wants to be in such a scenario? You want to be associated in a good software. And sometimes you might even think building a software that people get scammed from. It's possible. You just sit down, write code, push it, and people are losing their money on your software. But is it ethical? So sometimes it's good to look at these aspects, because that is going to really help you retain users and trust and growth when you're going to the industry with your software. So that has been it. It was a really brief conclusion of the series, but again, you can tie down as a storyline from the beginning all the way to the ethical implication and the cost. And I like to always mention about cost every time I get a chance to share, because most of the time we might overlook cost when we are developing. I want you to think of a pie chart. The biggest part of the pie chart, if I was to divide it into 2, that is development and production. The biggest part, the smallest part, is the development. When you're developing software, it might take you 3 months, but the same software might be used for over 10 years. So it's kind of it's kind of a fix, because you're supposed to make a decision in 3 months that is going to impact 10 years of time. And we might overlook cost when we are developing, but when stuff goes to production, that's where you find cost starts to affect you. Even in development, what are we looking at development? We're looking at maybe you had a team of, try to think big. You have a team of, let's say, 50 people working on a software, and they are using their time, and of course, they are getting paid, let's say, with time. If you have 50 engineers who are using 100,000 every month, and you have 5 months to complete a certain project, meaning a month, that's how much money? 550 times 100,000, that is 5 million, right? So if you made a decision that was a mistake and you lost 1 month, how much money did you lose? 5 million, because they have to go back to that. So during development, those are the losses that you're looking at. Maybe costs, labor costs, and all that. But in production, you're looking at way bigger losses, because if your system had subscribers, you had a subscription of, let's say, 3,000. Let's say the standard subscription was 3,000 Kenya shillings per month, and you had 1,000 users. How much is that? That's 3 million, right? So every month, your software, the standard subscription of your software is bringing in 3 million. But one day, a simple bug that was in the code when you were developing bytes when it's in production, and maybe some stuff, let's think of a worst case scenario. Data is lost. Someone was like deploying an update, and then the database, there was a code that was supposed to seed the database and flash, but that was supposed to happen in development, stuff that you do in your laptop when you're developing. But instead, the environment variable that was pointing to production was mistaken to the environment variable pointing to development, and it cleared all the stocks for your users, and maybe it was a point of sale platform, and all your customers wake up tomorrow and they have 0,000 in terms of sales and stocks, and you are gaining 3 million. So how much have you lost? You've lost trust, meaning that people who would have come back to your platform and subscribed are going to say, oh, it's not a quality platform, so we are moving out. So you're going to lose money even before you get to access it, and that is a big failure, just because of a simple decision that was involving programming standards. And that's why this is very important to consider. Professional practices, coding standards, ethical implementation, or if your users heard that you're using their data and selling it to their competitors, that's not ethical, because they trusted you to guard their data, but instead your platform was exposing their data to their competitors. So this stuff costs in the long run, and it's important to consider that, because right now we might be worrying about development. Is it going to work? But once it works, these are the stuff that you get to worry. And if your software was not scalable and good enough, then it becomes a failure from our side. So it's, as we develop platforms out there, as we implement anything, let's make sure we adhere to those standards, and make sure that we also think from an economic perspective or an entrepreneurial perspective, because whatever you're building is going to translate to some money. It's always good to think about cost with time, cost with trust, cost with even money itself. So that was my presentation, and any questions?